Okay, this is part 2 of topic 5, test review. Number 12, your school sold 456 tickets for a high school play. An adult ticket cost $3.50. A student ticket cost $1. Total ticket sales equaled $1,131. Let the scenario be represented by the system 3.5x plus y equals 1,131. X plus y equals 456. What do x and y represent? If the context of the situation, use Desmos to find out the number of tickets sold. So, what you're going to do first is we have to identify my x and y. I'm going to look to see what, so it says adult tickets is 350. That 350 went with the x. So that means x equals number of adult tickets, which then makes y equal number of student tickets. Okay. So then I'm going to go to Desmos and I'm going to graph these two systems. So it has 350 x plus y equals, I think it was 1,131. And then the second one is x plus y equals 456. X plus y equals 456. Of course, you can't see the graph, so you have to zoom out to find it. And then you're going to see where they intersect, 270 and 186. So it says find out number of tickets each one sold. So my x is 270? So 270 adult tickets and 186 students. All right, now we are going to 13 and 14 are just the same, so we're going to do one more. We will do 14. Two groups of students order burritos and tacos at a local restaurant. One ordered 3 burritos and 4 tacos, cost $11.33. The other order of 9 burritos and 5 tacos cost $23.56. Let this scenario be represented by the system 3x plus 4y equals 11.33, 9x plus 5y equals 23.56. What does x and y represent? And use Desmos to find the cost of a burrito and a cost of a taco. So first off, we have to figure out what x and y represents. The burrito, there's 3 burritos in one order and 9 burritos of another. There's 3x, 9x. 4 tacos of one order and 5 tacos of the other, 4y, 5y. So x is burritos. Y is the number of tacos. And then we're going to go to Desmos. And we have 3x plus 4y equals 11.33. And then we're going to do 9x plus 5y equals 23.56. So then, of course, I'm going to have to zoom back in because that looks like 0, 0, but we know that's not the case. So I'm going to zoom back in. And then that point is 1.79, 1.49. So one burrito equals $1.79 and one taco equals $1.49. All right, so 15, 16, 17, 18 are very, we're going to do, I'm going to do 15 and I'm going to do 18. Actually, I'll do 16 and 18 to kind of show you. So the first thing you're going to do is just go to Desmos and you're graphing it. So I have 2x plus 2y is less than 8. So all it's asking is for a point that at least 2 points that are solutions, or 2 solutions. So anything that's in this shaded region would be an answer. You could do 0, -5. You could do 1, 0. You could do -5, 0. You could do -5, 5. Anything in the shaded area. I would avoid the line. Now if I do through the systems, so like 18 is 3x plus y is greater than 2. And then my second one is x plus 2y is less than or equal to -1. Less than or equal to -1. So here it's the double region. So it's wherever the two regions cross, the shaded region. That's where your solutions would be. Okay? All right, so moving along. 19 and 20, you have to write the inequality. One for the inequality, the other for systems. So all you're going to do is you're going to start with finding your slope and your y-intercept. My y-intercept is 1. It crosses the y-axis as 1, so that's b. My slope is up 1, 2, 3, to the right 1. So 3 over 1 is just 1. So I'm going to have y, 3x plus 1. I don't know what way my sign's going to go yet. I have a dashed line, so I know I'm not going to have or equal. So I'm going to go to my Desmos. I'm going to say y is greater than 3x plus 1. Does that look like this graph? No. So let's change the greater than and put less than, and you can see it's the same thing. So you know it's going to be less than. Same thing with this one. First, I'm going to do this line right here. Where does it cross? Approximately the 2. My slope is 1, 2, 3 over 1. Negative, so -3. So I'm going to have y, -3x plus 2. It is a solid line, so I know I'm going to have it or equal. So again, I want to go back to my Desmos y. We're just going to say greater than or equal to -3x plus 2. That looks like it because it's above it, so we're going to go with that for now. And then the second one here, it crosses approximately at the -2. So that would be y. We have our slope and our y-intercept is -2. Goes up 1 over 1, so my slope is 1, so I have x minus 2. It is not a solid line, so it is not an or equal to. So I'm going to put this over here, my graph. Y is greater than x minus, was it 2 or 3? 2. That does not look like our graph, so I know it's not that. So I'm going to change this one to less than, and as you can see, it looks identical. So I'm just going to make sure these are the same. So that's like this. So my system is y is greater than or equal to -3x plus 2. Y is less than x minus 2. All right, 21 says, in the graph of an inequality, the area below a dashed line through the points -2, -2, and 3, -2 is shaded. Which inequality does the graph represent? Use the graph to help if necessary. So I'm going to put -2, -2, there's my point, and 3, -2. It's a dashed line, so it's going to be like this, and everything is shaded below it. So first, to start with, I know it's not going to be A or B because that's or equal to. I can go to Desmos and I can say, okay, y is less than -2 because that's where it crossed the y-axis, and that's exactly what it looks like. So it's C. In the graph of an inequality, the region to the left of a solid vertical line through the point 2, 0 is shaded. What inequality does the graph represent? So I'm going to go to 2, 0. And it's a solid line. So it does not cross through the y-axis at all. So I know I'm going to have x, and I'm going to have 2. And it's a shade to the left. So all of my x's are less than 2. So that's a 2. So there's your answer for that one. All right, so we have a few more. 23 says Ford wants to build cars and trucks on a budget. The company plans to spend at most $100,000 and use at least 250 workers to build cars and motorcycles. So 10,000 cars plus 6,500 trucks is less than or equal to 100,000, represents the numbers of cars C and trucks T the company can build by spending at most $100,000. 58C plus 42T is greater than or equal to 250, represents the number of cars and trucks this company can build by using at least 250 workers. Can the company meet both of its expectations by building 45 cars and 70 trucks? So I have to go to Desmos and plug that in. I'm going to do 10,000. C does not go in, so you have to change it to X plus 6,500. Y is less than or equal to 100,000. And then the next one is 58x plus 42y, plus 42y is greater than or equal to 250. So what it's asking is for 45 cars, 70 trucks. 45 cars is over here, and 70 trucks is all the way up here. So that would not be a solution. So your answer would be no. On these ones, you would plug this in here into the Desmos. And if that is, you go to 7.4 if it's just a solution. So we'll just actually do that real quick. Okay, so I went ahead and graphed this inequality, and I need to see if the 0.74 is a solution to the systems of inequality. So I am going to go to 7. So let's go up a little. Ooh, too much. There we go. 7, 4. So 7, 4. That is not a solution. That is not in the shaded area. So this first one would be no. Is -3, -5. -3 here. -5 would be, let's do -3, -5. No, it's not in the doubled region. So again, that would also be no. If I wanted to look at this one, what does X and Y represent? You want to make flower bouquets for your teachers. You will need at least 200 flowers to make bouquets. Roses cost $3 each and carnations cost $1. You can spend at most $300 on flowers. You have your situation or your scenario. You have your systems. So X is going to be roses and Y is carnations. So let's graph this inequality. Okay, so I graphed that, and we want to know if you can make bouquets with 20 roses and 230 carnations. So 20 roses is here, and 230 would be right here. And so that is in the shaded region, so that is yes.